So what is an exception and why do we care about exceptions in Java? Well, the basic thing that an exception is a way to handle errors. It's an error handling mechanism that's built into the language. Exception handling started being put into languages because of some of the problems with error handling techniques that were used before there was such a thing as exception handling. It could get very complicated. I'm going to show you some examples of that, and we are going to kind of talk about this in a little bit here. But basically, exceptions are just a way to indicate that there is an error and to handle that error. Now in Java, an exception is basically a special object that indicates that there has been some kind of error or exceptional situations that needs to be handled. The code needs to be halted if it's not handled. And in Java, all exceptions basically inherit from a common type called a throwable. So there is basically any class or object belonging to this tree hierarchy that starts with throwable. And exceptions in Java have the ability to end your application. If you throw an exception in Java, or there is some code that throws an exception in, that exception isn't handled or dealt with in your Java program. It's going to actually crash that program, and that is by design, and that's kind of important because the idea here is that if something happens and it's an error condition that you didn't expect or your code isn't able to handle, we don't want to just keep on going through, because even though crashing an application is a bad thing, the worst thing is to corrupt data. Really, when you talk about the severity of errors that happens and that annoy users, really the worst thing you could possibly do is corrupt data. And really the worst extreme of that is to corrupt data without anyone knowing it, because months could go by and you are building on corrupted data. So really the purpose of exceptions is to indicate there's an error and indicate that if it's not dealt with, this application is going to crash. And usually that's better behavior, that's a better behavior than corrupting data. So let's kind of look at how exceptions work in Java and try to understand why they exist. So as I said before, exceptions are they are better than error codes. If you have a C background, even C++ background to some degree, but more so kind of low-level C programming, you are probably familiar with error codes. And a lot of people have come up with a lot of clever ways to implement error codes. Some people have stuffed them into arrays of bits, or basically bit flags, things that allow you to basically figure out what went wrong in the program and have a variety of different error codes. And maybe you have even programmed it this way before. Maybe you have done this in Java or in C# or in C++, where you have started returning back an integer or some kind of string or something that indicates what kind of error had happened. Well, exceptions are kind of designed to defeat that because of kind of a problem that can occur in that case. I have a diagram here where I am showing some method calls, and you can see here we have method A is calling into method B, and then method B is calling into method C, and then method C hit an error. It hit a condition that it needs to deal with that it cannot deal with. So method C can't handle this problem. It's an error. Maybe it opened up a file and that file didn't exist. So what's going to happen here if you didn't have exceptions? Well, without exceptions, the standard way that you would have to deal with this problem is method C would need to be able to check for that condition and then return some kind of error message. Maybe even it just returned true or false, and it would have to return false back down to method B, and then method B would then have to return that message back up to method A, and then method A would have to deal with it or return it from wherever it called it. So you end up with this problem, especially if you are doing refactoring. If you have ever written some error handling code like this, and then you have refactored that code, maybe you have taken out another method, you have done the extract refactor to take some code and put it out and make a method out of it, then you have realized that you now have to return a value from that method, an error code or a true or false. And you have to bubble that all the way up the stack here. So an exception basically works the same way as this, except that it is automatically going to look up the stack of method calls for a special clause, which is a catch clause that is able to handle that exception. So in Java we use this concept. We basically say, okay, in that scenario we would have maybe method A calls method B, and method B calls method C. Method C tries to read some file on disk. It doesn't exist, so method C throws an exception. Now that exception is going to say, hey, is there somewhere up the stack that can handle me? It's going to look in method C first, where it originated. Can you handle me? Have you said that you can handle me? No, it's going to look in method B. Can you handle me? No, it's going to look in method A. Can you handle me? So yes, okay, and then it will be handled. So this is going to prevent you from having to return back an error message or error conditions or error codes, and instead method C is going to be able to return back maybe what it should. Maybe it's supposed to return some text from a file. Instead of trying to overload these methods, return it in order to bring back error codes. So that's kind of the big picture of why we have exceptions in Java and what they are doing for you. And we are going to get into the code now and start to look at how we can actually implement this. And you know, the basic way that this is implemented in Java is that you have what is called a try block, and you put your code inside of this try block, and then you have a catch block, and that catch block really tells the compiler, okay, if an exception gets thrown, I can handle this exception, and then you can do something useful in order to be able to either repair the data, repair the damage that is being done, display an error message, or whatever you can do with when that error occurs.